Hypersonic flight is the next frontier of aviation technology. It means traveling at speeds greater than Mach 5, which is 5 times the speed of sound. At sea level, this is over 6,100 kilometers per hour. To put that into perspective, a commercial jetliner flies at around 900 kilometers per hour. Hypersonic speed is so fast it could get you from New York to London in under an hour. This incredible velocity is not just about making travel faster, it's about changing what is possible in defense, space exploration, and global transportation. It represents a monumental leap forward in engineering and science, pushing the boundaries of human achievement. The reason this speed matters so much is because of the advantages it provides. For military applications, a hypersonic missile is nearly impossible to stop. Current defense systems are not designed to track or intercept objects moving that fast, and that can also maneuver unpredictably. They fly too high for traditional anti-aircraft systems and too low for space-based missile defense. This makes them a powerful strategic tool. For civilian use, the potential is equally transformative. Imagine crossing continents in the time it now takes to watch a movie. It could revolutionize business, tourism, and emergency response, connecting the world in ways we can only begin to imagine today. Achieving these speeds is incredibly difficult. The air resistance at such velocities generates immense heat, capable of melting the strongest metals. The engines required to produce the necessary thrust must operate under extreme conditions that would destroy conventional jet engines. This is why developing hypersonic technology is a major national achievement. It signals a country's advanced scientific and industrial capabilities. Nations that master this technology will hold a significant advantage, both economically and militarily, shaping the global landscape for decades to come. The race to conquer the hypersonic realm is well and truly underway among the world's leading powers. Recently, China has made a stunning announcement that has captured the world's attention. In late June 2025, a test flight of a new hypersonic aircraft called the Feitian-2 reportedly achieved breathtaking results. This event was not just another incremental step. It was a major breakthrough that suggests China may be pulling ahead in this critical technological race. The Feitian-2, developed by the US blacklisted Northwestern Polytechnical University, is more than just a fast missile. It's a reusable, autonomous aircraft, a vehicle designed to fly to the edge of space and return, paving the way for a new generation of flight. The Feitian-2 test flight was a showcase of remarkable achievements. The aircraft reportedly reached a top speed of Mach 12, which is 12 times the speed of sound, or approximately 14,800 kilometers per hour. During its flight, it performed a series of complex maneuvers completely on its own, demonstrating a sophisticated level of autonomous control. This is crucial for a vehicle traveling at speeds where a human pilot would be unable to react in time. The aircraft managed sharp turns, adjusted its own thrust, and even changed its physical shape to adapt to the intense stresses of hypersonic flight, all while collecting valuable data for future missions. One of the most impressive feats of the Feitian-2 was its unique engine system. The aircraft uses what is known as a rocket-based combined cycle, or RBCC engine. This clever design combines 2 types of propulsion into a single unit. It uses a rocket to blast off from the ground and reach high speeds. Then, once it is flying fast enough, it seamlessly switches to an air-breathing ramjet engine. A ramjet inhales oxygen from the atmosphere to burn its fuel, making it much more efficient for long-distance cruising than a rocket, which must carry its own heavy oxygen supply. This mid-air engine transition is an incredibly complex engineering challenge that China has now demonstrated. This success did not happen overnight. It builds on years of dedicated research and previous experiments. For instance, in August 2021, Chinese scientists tested a different prototype that reached Mach 6.56 over the Gobi Desert. That earlier vehicle was designed with a bulky fuselage, hinting at ambitions to one day carry heavy cargo or even passengers. The long-term vision behind these projects is incredibly ambitious: to create aircraft capable of flying from Beijing to New York in just 2 hours. The Feitian-2 test brings that science fiction dream one step closer to reality, proving that the core technologies are becoming more mature and reliable. The reusability of the Feitian-2 is another key feature that makes it so significant. Unlike a single-use missile, the Feitian-2 is designed to complete its mission and then glide back to Earth for a conventional landing, just like the old space shuttle. This ability to be used again and again dramatically lowers the cost of operations. It opens the door for a fleet of hypersonic drones for rapid surveillance or even crewed vehicles for quick entry and exit of contested airspace. The test flight in June 2025 was more than just a speed record. It was a proof of concept for a practical, reusable hypersonic platform. Alongside the Feitian-2, Chinese researchers have been developing another groundbreaking piece of technology, the Oblique Detonation Engine, or ODE. In a ground test conducted in February 2025 at the Advanced JF-12 Shock Tunnel in Beijing, this engine demonstrated stable operation at speeds up to an astonishing Mach 16. What makes this engine so special is its efficiency and power. It works by creating a continuous supersonic explosion that generates immense thrust. This process is far more powerful than the combustion in a traditional scramjet, allowing for much higher speeds and greater fuel efficiency, which translates to longer range. A major breakthrough with the ODE test was the fuel it used. The engine successfully ran on standard RP3 aviation kerosene, the same type of fuel used by regular commercial and military jets. Previous hypersonic engine designs often required highly volatile and difficult-to-handle fuels like liquid hydrogen, which must be stored at extremely cold temperatures. Using common jet fuel makes the technology far more practical and easier to deploy in real-world scenarios. It simplifies logistics and reduces costs, removing a significant barrier to the widespread adoption of hypersonic flight. This development makes the prospect of a hypersonic aircraft fleet much more realistic. These advancements are causing significant concern in other countries, particularly the United States. Hypersonic weapons fundamentally challenge existing military doctrines and defense systems. Their speed and maneuverability create a window of vulnerability that nations are scrambling to close. The Feitian-2 test is seen by many as a clear signal of a new phase in the global arms race. It suggests that China is not just catching up in hypersonic technology, but is potentially establishing a lead in certain areas. This shift could alter the strategic balance of power, forcing other nations to accelerate their own research and development programs in response. What makes China's progress even more notable is that it has been achieved despite significant international pressure. Northwestern Polytechnical University, the institution behind the Feitian-2, is on a US government blacklist. This means it is subject to strict export bans designed to prevent it from acquiring American technology that could be used for military purposes. The success of the Feitian-2 and the ODE tests demonstrates China's growing technological independence. It proves that the country can innovate and achieve major milestones on its own, raising serious questions about the effectiveness of sanctions in slowing down its military modernization efforts. Despite these impressive breakthroughs, China still faces enormous challenges before hypersonic aircraft like the Feitian-2 become a common reality. The single greatest obstacle is heat. At speeds like Mach 12, the friction with the air creates temperatures hot enough to vaporize steel. Developing new materials and advanced cooling systems that can withstand this extreme environment for sustained periods is a monumental task. The materials must be both incredibly heat-resistant and lightweight enough for flight. Finding the perfect balance is one of the toughest problems in material science, and it's a hurdle that all nations in the hypersonic race are trying to overcome. Another significant barrier is cost. Building and testing these advanced aircraft is incredibly expensive. The research requires state-of-the-art facilities like wind tunnels that can simulate hypersonic conditions. The materials themselves are exotic and costly to produce. Each test flight, even of an uncrewed prototype, carries a huge price tag and the risk of catastrophic failure. For hypersonic technology to become practical for widespread use, whether for military or civilian purposes, the costs of production and operation must be brought down significantly. Until then, it will likely remain a niche capability reserved for only the most critical missions. Beyond the technical and financial hurdles, there are also practical considerations for real-world operations. A hypersonic aircraft requires a completely new infrastructure for support, maintenance, and logistics. For military use, integrating these weapons into existing command and control networks is a complex task. For civilian travel, questions of safety, regulation, and environmental impact, such as the effect of sonic booms, would need to be addressed. These are not small details. They are fundamental challenges that must be solved before passengers can board a hypersonic jet for a 2-hour flight across the Pacific Ocean. Looking to the future, the path is both exciting and uncertain. The Feitian-2 test has undoubtedly accelerated the global hypersonic race. We can expect to see increased investment and more frequent testing from the United States, Russia, and other nations as they work to counter China's progress. The technology will continue to mature, with new engines, materials, and control systems being developed. While the dream of routine hypersonic travel may still be decades away, the military applications are much closer. The world is now on the cusp of a new age defined by speed, and the recent events in China have made it clear that this future is arriving faster than anyone expected.